Our team has developed a testing fixture for Agile Therapeutics cryoablation therapy targeting type 2 diabetes. The testing fixture will be used by Agile Therapeutics to characterize the cryoablation therapy's energy output into the duodenum of the small intestine. Let's first dive into the design of the testing fixture. Here, we can see the completely assembled testing fixture, which is composed of 3 components. First, we have the shell of the testing fixture, which will hold the other 2 components. The shell also serves as the main mold for agar, which will be used to mimic the tissue of the small intestine. Next, we have the central rod component. This rod is placed within the testing fixture to create an artificial cylindrical space, mimicking the lumen of the small intestine. Finally, we have the sensor module, which holds the thermocouple sensors. The sensor modules can be inserted in various positions within the testing fixture to collect temperature data at various locations. Now, let's look at how the testing fixture is assembled and used. The first step of the assembly process involves preparing the agar. We use a 2.3 gram to 100 milliliter ratio of agar powder to water. The mixture is placed on a hot plate and allowed to reach its boiling point. While the agar is heating up, PVA is applied to the interior of the shell as well as the central rod. This prevents the agar from sticking to the mold during the setting process. The 2 shell components are then put together with the central rod placed between the shells. Screws are inserted to keep the testing fixture together, and a rubber gasket along the edge of the shells prevents leakage of the agar. With the shells and rod now in place, we can now insert the sensor modules. Each module slides into a shell compartment, and the location of the modules can be varied based on where the user wants to collect temperature data from. Here is a close-up image of the sensor module. Each module contains 4 thermocouple sensors positioned at 0.5 mm increments to allow for temperature measurements at various steps within the mimicked small intestine. Now that the agar has begun to boil, we take the mixture off of the hot plate and allow it to cool. With the agar cooled, it is now ready to be poured into the testing fixture. To decrease the presence of bubbles in the agar, the pouring process can take place in a vacuum chamber. The agar-filled testing fixture is then placed in a refrigerator to accelerate the cooling process. Once the agar has cooled and solidified, we can begin loosening the screws holding the shells together. This allows us to take out the central rod, exposing the cylindrical space within the agar where the cryoablation apparatus will be inserted. The thermocouple sensors are then connected to the DATAC device, which will be used to collect the temperature data. Each thermocouple will connect to the positive and negative terminals of a single channel on the DATAC device. Here, we can see 4 thermocouples connected to 4 separate channels. Here is the user interface of the program used to run a temperature collection trial. The user can first select the number of sensor modules that are being used for the trial. The user then presses start, and the temperature collection commences. Throughout the trial, the temperature data can be visualized in 2 ways. First, in a graph located on the left of the user interface, with each line on the graph representing a single thermocouple. Temperature readings can also be seen in real time through the temperature indicators located on the right. Here is a brief demonstration of the data collection program in action. For demonstration purposes, a compressed can of air is being used to inject cold fluid into the testing fixture, and the colder temperatures can be seen by the decrease in both the graph and the temperature indicators. After the trial is completed, the data is stored in an Excel file which can be accessed after the trial for analysis. One possible amendment to this procedure is to completely remove the agar from the shells of the testing fixture. By placing the agar sensor construct in a warm water bath, temperature distribution will be more physiologically accurate to the duodenum of the small intestine.